All right, welcome back, and here we go. Example number 3, let's go through and graph this sucker. So again, first thing we're going to do is we're going to look at what? We're going to look at y and x-intercepts. So y-intercepts. Y-intercepts are f of 0, right? So when we're looking at y-intercepts, we look at f of 0. So that means we're going to set the numerator equal to 0, or excuse me, look for values of x that will make the numerator 0. In this case, the only value of x that will make it 0 is 0. Now, the other thing too is keep in mind, if you have a polynomial on top, you can factor it too, right? Use the zero product principle for the numerator. In this case here, it's already in factored form. If you there's no other factor than 4 and x. So that means the y-intercept is going to be at what? The y-intercept is going to be at 0, 0, which is also an x-intercept, right? So right away we have an x-intercept at 0, 0, right? Now, the x-intercept is all of the values of f of 0, right? So if you look at the x-intercept, you take the y-intercept is f of 0, right? So where does it intersect the y-axis when x is 0? The other one is when y is equal to 0. So this is equal to 0. So you get the x and y intercept are one and the same in this case. Okay. What else? Oh, next are the asymptotes, right? So let's start with vertical asymptotes. So vertical asymptotes. What do we focus on for vertical asymptotes? We look at the restricted values of the function, of the domain. In this case here, we're looking at the denominator. So we're going to factor the denominator and then use the zero product principle. So we're setting the denominator equal to 0 and solving the denominator, right? So in this case here, this is a perfect square, right? So this factors in x minus 2 and x plus 2. So that means we have a vertical asymptote at x equals plus or minus 2. Okay, good. Now what about horizontal asymptotes? Is there a horizontal asymptote? And the answer is yes, there is. The horizontal asymptote is at y equals 0, and the reason why we know that is because the degree of the bottom is bigger than the degree of the top. Okay? So now we know that there's a horizontal asymptote, so there cannot be any oblique asymptotes. So the horizontal asymptote is going to be at y equals 0. Okay? We know that because the degree of the bottom is bigger than the degree of the top. All right, good. Now, what do we do now? Now, we're looking at, does it cross the horizontal asymptote? Okay? So the horizontal asymptote is at 0, so what we want to do is we want to set this equal to 0 and see if we can solve this equation. Well, if we multiply both sides by x squared minus 4, what do we get? We get 4x equals 0, which is going to give us x equals 0. Now, that should make sense, and by the way, if you realize something, you don't even have to do this because we know that the horizontal asymptote is the x-axis. Now we already know that there's an x-intercept at the origin. So we already know where it crosses the horizontal asymptote. Now the good news is that's the only place that it crosses the horizontal asymptote because we just solved it and we only got one solution. which was x equals 0. Okay? So now that we got that, so we know cross is at the origin, but we knew that already. What else? Oh, symmetry. Can we use symmetry here? And here, if you look at symmetry, if you look at negative x, let's say plug in negative x, here, if you plug in negative x, you actually get the opposite of f of x. Okay? Because if you plug in negative x here, you get negative 4x. If you plug in negative x here, you just get x squared again. And so you pull out the negative, and you can get the negative of f of x. So this is symmetric with respect to the origin. Okay? So we might be able to use that. Okay? So that's good. So now let's plot some points. Okay, so now we've got our, let's go ahead and plot what we know. Okay. Okay, I don't know if this will help us, but let's plot this. Okay, so here we go. So intercept, x and y intercept is right here at the origin. Good. Our vertical asymptotes are at plus and minus 2. So that's going to be here and here. All right. And then we also have the horizontal asymptote at the x-axis, which is right here. Okay. And so now look what we have. We have this interval, and this interval. Okay? So we want to test a point in this interval. So let's do -3. Okay? So if we do -3, what happens? Well, we got a negative. This is negative up here. This is going to be negative. This is going to be negative. Right? So what do we get? -3 is going to give us a negative here. And that's going to be positive, so we'll have a positive denominator and a negative. So this whole thing will be negative. So we're going to be in here. So this is going to be negative. If we're in this interval here, right, where are we at here? So in this interval, let's do -1. If we do -1, we're going to be negative, positive, which is going to give us negative. This will be negative, so negative divided by negative is positive. So we're going to be positive up here. And then let's put in 1. 1 will give us negative here, positive here, and positive up here. So let's do this. So this will be -1. This will be negative. Negative times positive is negative. And then positive divided by a negative is negative. So we're going to be negative, which means we're going to be down here. And then here, over in this area, where are we going to be here? So let's do 3. So 3 will give us positive here, 3 will give us positive here, and 3 will give us positive. So it's all going to be positive. So that means we're going to be up here. So now, look what I did. So I know I'm going to be in this area here. And in this corridor here, I'm going to be above the x-axis. In this interval here, I'm going to be below the x-axis. And in this interval here, I'm going to be above the x-axis. So now I know what I'm going to post, right? So now here's the thing. At 3, let's do -3. So -3 is going to give me what? -12 over 7, right? So -3, or excuse me, I'm sorry, 5. So this is going to give me -12 over 5. So -12 fifths So it'll be less than negative, it'll be more than negative 3. So if we're at negative 3, it's going to be negative 12/5. So it's 2 2/5, right? Negative 2 2/5. Oh, down here. So negative 2 2/5. So it's going to be right at, right around here, I guess. Just estimating. Okay? And now as I get closer, now what's happening here? As I get closer to negative 2, what's happening as I get closer to negative 2 from the left? Well, as I get closer and closer to negative 2 from the left, this is going to be negative. Right? But if this is negative 2, this is just going to go to negative 4. This is going to 0, but this is it's negative, but it's getting closer to 0, but it's still negative. This is going to negative 4. This is going to negative 8, but this is going to 0. So this whole thing is going to what? Negative infinity. So this is going down like that. Now if I go off to negative infinity, what's happening here? Well, this is going to negative infinity, this is going to negative infinity, which is going to be positive. Right? Well, what's happening? Well, as this goes to negative infinity, remember what's happening here. It's going to what? 0. Right? So we know that this is going towards 0 from what we talked about earlier. So this is just going to go towards 0. But also, like over here, what's happening over here? Now, I'm over here on the positive side because but I know that this is going towards 0. Now, at positive 3, what's happening? At positive 3, this is going to what? This is going to be positive. Remember? Symmetric about the origin. So this is going to be what? Instead of negative 3 in the negative 12 fifths, this is going to be positive 3 in positive 12 fifths, which is going to be right about here. So 2 and 2 fifths. And we know that since it's symmetric about the origin, this is going to do this. Look at that. So this and this. Right? Now, we know that it crosses here at the x and y intercept. And we know that it's above the x-axis here, and it's below the x-axis here. So, and here we know it's not going to cross here. So it stays positive, right? So it's probably going to do something like this if I was going to guess. Because it's symmetric about the origin. So it probably does something like this. Because it's an odd function. So if you rotate this 180 degrees, you get the exact same graph. And again, you could plot some extra points. You could plot -1 here, and you could plot 1 here, and plot a couple extra points. I would, if you wanted to get a clearer picture. So we call that doing test points. We do a test point here, test point here, test point here, test point here, see what's going on, and then look at end behavior. What's happening when x goes to negative infinity and positive infinity? What's happening to x as you get closer and closer to the vertical asymptotes from both sides, right? We talked about that in previous videos. Now what we're doing is we're putting it all together to graph.